This is the second and last lecture on habituation, and we're going to be talking about the properties of habituation. We learned before that habituation is the simplest form of learning. It's a reduction. So oftentimes it's called non-associative learning because there is no association involved in habituation. And it involves the reduction in responding and the magnitude of our response due to the repeated presentation of a relevant stimulus. Now, there are a number of properties that habituation has that it's important to understand this phenomenon. But let me warn you first, if you have not seen the videos on habituation, dishabituation of a startle response, which are the links are posted in Blackboard, then please go back and check those. Then come back. All right. We're going to be talking about the following properties: spontaneous recovery, relearning effect, interstimulus interval effect or ISI effect, the stimulus intensity effect, dishabituation. This is an important one because this is not in the workbook. This is not discussed in the workbook, dishabituation. So I may spend a little bit of more time talking about that one. And stimulus generalization and specificity. Okay. What do we mean by a spontaneous recovery? Recall the graph that we draw. That we show that we have the duration of a orienting response. I'm going to use that as my example throughout. Orienting response, right? And we have it in seconds, and we said that it was something like 30, this is 0, and we have a few values in between, and we have presentations of stimulus. And so if we present this stimulus repeatedly and this orienting response is habituated, what we mean by that is that there is a decline in the magnitude of that response with repeated presentation of the stimulus. Right? Now, notice one thing is that I am assuming here that two consecutive presentations, like this one and this one, two consecutive presentations of the stimulus are separated by the same interval as these other two presentations. These are what are called the ISI or interstimulus interval. I'm presenting this stimuli in a somewhat periodic way, and I'm presenting them relatively close to each other. So I may be presenting the stimulus every 30 seconds or so, and I may or maybe a little bit more, and I'm checking how long the infant is looking at that stimulus. As I'm going through this, think of your own example, a different example of a habituated response, maybe with a reflex or a startle response or something like that. But because these ideas, although I'm illustrating them with the orienting response, they apply to any habituated response. In any case, I was saying that there is a relatively short ISI. So I'm going to write, short between consecutive presentations. Let's say up to here. And then this one, we're going to make it a very long ISI. Maybe this happens the next day, right? 24-hour ISI. And I look at what happens to the presentation of this stimulus, what is the duration of the response it elicits, and I will see that maybe it didn't go. If it's 24 hours, probably went all the way back to a baseline, to the first response that I observed to this stimulus. And then presumably this comes down again. Well, the ISI doesn't have to be that long. This long ISI, it could have been just a few more minutes longer than the previous ISIs. And in that case, maybe I could have seen something that looks a little bit more like this. Oh, sorry. Like this. So there's not a complete recovery of the response, but a partial recovery. In any case, the difference between these two, the recovery in the magnitude of the response, of a habituated response, due to the passage of time, is what we call spontaneous recovery. It's an important property of habituation. Alright. The other effect is the relearning effect. And it's not completely obvious here, but one of the things that I tried to do to illustrate this relearning effect, let's see if I can erase this, alright, is to illustrate this relearning effect is to make this curve a little bit steeper. Let me try it again. Let's suppose that we have really a full recovery of the response in this ISI, but maybe you find a decline that is a lot faster the second time around. And the difference in the steepness of these two curves, this relatively slow, this relatively fast, is what we refer to as the relearning effect. A habituated response that is recovered, typically the second time around, is habituated much faster. Okay. The next one is the ISI effect, and that refers to the effect of the length of this ISI on the speed of habituation, of the steepness of this curve. With short ISIs, we see steeper habituation. With more separated ISIs, we may see something that may look something like this. Flatter decline in the magnitude of responding. Slower habituation. Alright. The next one is the stimulus intensity effect. And that simply says that the stronger, the more intense the stimulus, the habituated stimulus is, the longer it's going to take to habituate. So again, I may draw a similar graph as I did before, where this one corresponds to a relatively weak stimulus. I'm sorry, not a weak stimulus, on the contrary, a strong stimulus. And this is a weak stimulus. And the strong stimulus a response to the strong stimulus habituates faster than the response to the weak stimulus. Alright. Next one is the one that I want to spend a little bit more time talking about, which is dishabituation. Let me erase these last few things I did here. And by dishabituation, what we mean is the following. Let's say instead of presenting here a long ISI, I present here in between, these ISIs don't change, but I present right in the middle of this ISI, I present a novel stimulus. The stimulus doesn't have to elicit a response. It just has to be new and has certain characteristics that produces this habituation. But it doesn't have to elicit the habituated response. So in the example of an orienting response, it may be a sound, and the sound may not elicit an orienting response in itself. May not. And then what we do is we show the habituated, the stimulus to which the orienting response is habituated, and what we may see is, yes, a recovery, and then again a decline, of course, over repeated presentation of that stimulus. You saw that with the startle response of the rat, where there was a dishabituating stimulus that was presented, that was a loud sound of a different frequency, and that made the original startling response to be recovered. But what's a little bit confusing about that is that the novel stimulus did elicit something that looked like a startle response, and that often confuses people. The novel stimulus doesn't have to elicit the habituated response. It's a very important idea. Alright, and the last characteristic that I wanted to talk about, and it's a very important one, is stimulus generalization and specificity. What this implies, the idea that of a stimulus generalization and specificity, is the following. Let me erase this. Okay. So you a response to a particular stimulus has been conducted, it has taken place, and now if this might have been a stimulus of a particular kind, stimulus A. I think in the example that you saw in the video was cayenne pepper or something like that. Was the a jar of cayenne pepper was the stimulus that elicited the orienting response. Doesn't matter. I'm gonna call it stimulus A. And suppose that on this trial, instead, this trial right here, instead of presenting stimulus A, we present stimulus B. A different stimulus that by itself would have normally elicited an orienting response. What do we expect will happen? Well, one possibility is that we may see a full recovery of the response. The other possibility is that we don't see much of a recovery. So this is either one of these two could be stimulus B. In what situation do we see one pattern, say this pattern, and in what situation do we see this other pattern? Well, it depends on how similar a stimulus B is to stimulus A. If stimulus B is very similar to stimulus A, then we're talking about this situation. And what we see is a continuation of habituation from the previous, the habituation process that had been conducted before, because B is very similar to A. But if B was very different from A, we would see a recovery of responding, because we're talking about really about a new, a different stimulus. So this is really interesting, because this allows us to ask a non-verbal organism whether the stimulus we're showing to them is similar or different from the previous stimulus we showed them. If we show them a new stimulus, B, we don't know if it's similar, if it's different from A. But if we see, to the extent that we see a recovery of responding, so it would suggest that stimulus B, the second stimulus, is for this organism very different than stimulus A. But if we see a continuation of the habituation curve, well, that would suggest that stimulus B is very similar to stimulus A. Alright. Okay. Let me draw this in a slightly different way. We're going to draw something that is called a generalization gradient. So suppose that this doesn't look good. Suppose that instead of trying just one stimulus B on this trial, on this test trial, what we try is a lot of different stimuli that are different or similar to to different degrees. So this is response magnitude. And so A, of course, we have a stimulus, so this is stimulus B, but this is a stimulus B. So here we present the stimulus B that is identical to A. Identical to A. So we expect very little responding to that stimulus. Let's put it this way: similarity to stimulus A. Alright, and let's put it this way. So now here this is 0, and maybe this on some sort of dimension. Maybe what was used as a listing stimulus was a sound of a particular frequency, and so we may vary that sound on a particular dimension in one direction or the other. So maybe this is lower frequencies, higher frequencies. But the thing is that if we use exactly the same stimulus we used before, we would be located here. And what we would expect is that we use the same stimulus. Well, we'll get very little responding. If we use similar stimulus, we may get a little bit more responding, but still pretty low. And then maybe more responding. And overall, we may see something like this: less responding, that's more similar, that test stimulus. This is stimulus B, our test stimulus. The more similar stimulus B is to A, we see less responding, and the more dissimilar it is, we'll see more responding. And this is what we would call generalization gradient. We talk about stimulus generalization when similar stimuli produce similar responses following to a habituated stimulus. But we also talk about stimulus specificity in the sense that the response that was habituated is not just a general response. It's not just the orienting response in general, or a startling response in general, but it's an orienting response to a particular stimulus, an orienting response to a startling response to a particular stimulus. Similar stimuli would also be responses to similar stimuli will also be somewhat habituated, but other stimuli that may elicit also an orienting response or a startling response or whatever it may be your habituated response. Those stimuli, if they are different enough from the training stimulus, from stimulus A, they may not, the response to them may not have been habituated. Right? And this is an important point, not only because of the implications that I was talking about here, about having an organism tell us whether something is similar or different, but also because this is the basis for distinguishing habituation from sensory adaptation in motor fatigue. Why so? Because if you think of this, in the case of sensory adaptation, I used an extreme example in the previous video where I present a loud noise to elicit a startle response, and I may see that startle response going away because you essentially went deaf. My stimulus was way too loud. But what does that mean when I try to use a very different stimulus that it's also supposed to elicit a startling response and was not supposed to be habituated? Well, when I do that, what I will see is that I will see very little responding from you. One of two things might have happened. Either there was a huge generalization of the training stimulus, or more likely, you went deaf and you are incapable of responding to auditory stimuli. So the reason why sensory adaptation is not habituation is because it is not stimulus specific. Any stimulus in the same sensory modality would not be responded to if you have undergone sensory adaptation. Now, motor fatigue is the idea of motor fatigue is very similar, and it's the idea that if I show you a different enough stimulus, I should be able to elicit a non-habituated response from you. So, take for instance the orienting response. I can rule out motor fatigue as an explanation for the reduction responding to an orienting eliciting stimulus. I can rule it out by changing that stimulus to a new stimulus that also elicits the orienting response. To the extent that I am able to elicit that orienting response with a new stimulus, that means that you are still capable of producing that orienting response. And the reduction orienting response that I observed before with the repeated presentation of a stimulus was due to habituation. That's how you rule out motor fatigue.